Okay. Right on the front. Sure. Gonna start the lesson, but you can go. That's usually when I try to leave the classes, right when instruction's gonna start. Just saying. It's your choice. I gave you permission. You can go or not. But I'm starting the lesson. Box plots. Today we're going to talk about comparing them. And in a box plot, there's 5 pieces of data that are important. And it separates everything into quartiles. Q1, Q2, Q3, and Q4. If you would, please put those on your plot there. Q1, Q2, Q3, and Q4. How much of the data is in each one of those sections? 25%. Whether it's all crunched together, it's really short, or whether it's all stretched out, it's really long. If it gets really long in a section, it just means that the range of that quartile is larger. It's easier to make predictions when the range is what? Smaller. Now, it's also important to make note that there are 2 pieces of data, and only 2 that I know for sure came from my original data set. What does the 15 that's here represent? The what? The lowest point. That number came out of my data. How about the 30? What does it represent? It represents the highest point. That number also came from my data. Nothing else that's on there had to have come from my data. It could have, but it didn't have to. What does this point that's between Q2 and Q3 represent? It's the median. In other words, it's the actual center of my data. Does that mean that 21 was part of my data? Yes or no? No. Not necessarily. It's possible that 20 and 22 were my 2 numbers that were in the center, and then I have to average them together to get my median. So the only 2 points that I know for certain came out of the original data set are the low and the high. Are you okay? The other thing that's important here is this box. And it is called the interquartile. And the interquartile is where we do most of our predictions from. Can anybody tell me why? Why would I want to predict from the interquartile versus any other place from a box plot?
Because that's where everybody's in. Where everybody's...
Not everybody, but what?
The average.
The majority. 50% are in the box. 25% are below it. 25% are above it. But 50%, the majority, are in the box. That's where we typically make our predictions from. So, let's take a look at the questions it asks. Some of them are easy. What's the least value? 15. Fill it in. What's the greatest value? 30. What's the median? $21 is what the median is. It says, and describe what it means for this data. The median is 21. Describe in terms of this data what it means.
More people are closer to 15.
Half score more than 21. Half score less than 21 points. That's what the median tells me about this data. They're talking about points that a basketball player makes. So the one that's in the middle makes 21 points. It means half the people make more than 21 and half the people make less than 21. Everybody good with A and B? Good? Evan, okay? C. Find and describe the lower and upper quartiles. What's the lower quartile? Where does it start?
At 15.
Starts at 15 and goes through what?
30.
The lower quartile. Lower quartile goes from 15 to about 17.5. Don't do that. Dang it. So the lower quartile goes from 15 to about 17.5. What's that for a range? What's the range of the lower quartile? 2.5 is the range. Remember, we find it by subtracting. What's the upper quartile? Where does it start?
At 17.5.
Where does the upper quartile start? About 27.5 and goes to what? 30. What's the range? About 2.5 again, isn't it? Right? So you'll see that the range in the lower quartile and the range in the upper quartile is about the same. There's about a 2.5 point range. In other words, everybody in those quartiles pretty close together in terms of basketball, because 2 points is what? One basket. 2.5 points is the difference between a basket and a 3-point shot, or making one free throw. So they're pretty close together. Everybody good with C? In D, it asked me to find the interquartile range. Remember, the interquartile goes from Q1 all the way to the end of Q3. Right? So, it goes from 27.5 on the high end down to 17.5 on the low end. What's the interquartile range? 10. In other words, 50% of that basketball team is within 10 points of each other. 5 baskets.
Is that 30 on number 2? That's the 30. That's 36.
Yeah, it's 30. Yeah, I knew it was going to do that too.
Like, you might not add that there, but I'm confused, like, the mean, I'm confused, like, what a mean is.
Mean is an average. You have to add all the pieces of data together and divide by the total. Can I find the mean in a box plot?
Yes.
No, because I don't know any of the data except 2 points. Can I find the mode in a box plot?
No.
No, because I don't know which data point occurred the most.
Can you add them up and divide by 2?
No, you divide by the total number of pieces. Like if I'm talking about the rainy days per month, okay? And I add it up for the year, and I'm getting a monthly average. What would I divide by?
12.
12, because there's 12 months in a year. If I wanted a daily average, what would I end up dividing by?
365.
365, because there's 365 days in a year. Everybody get that? If I was looking at the average for 1 month, then it might depend on which month I was looking at, right? Because 30 days has September, April, June, and November. All the rest have 31 except February, which has 28 or 29, like it did this year. Yes.
But it got like
So, how many months have 28 days?
0.
All of them.
Oh, yeah.
They all have 28 days. Most of them have more.
Is this year
A leap year,
Okay.
Rajan.
So like in a dot plot, like you gotta add like all the dots up. Add all the dots.
In a dot plot, you have to add up all the values of the dots and count how many dots there were and divide by the number of dots so that you can find out the average.
It'll be 1.
No. I'll go back to that. Okay? I'll give you a dot plot and show you how to find it. Do we understand this? Are we good? Here? So, on the reflect, why is 1/2 of the box wider than the other half of the box? Be careful before you answer. Why is Q3 longer than Q2? What would make that happen? Anybody want to take a guess at it?
Is this on the reflect number 1?
This is on the reflect number 1. Why is 1/2 of the box wider? Q3 is wider than Q2.
Because the range is larger.
Absolutely, and a very good answer. The range in Q3 is greater than the range in Q2. It has nothing to do with how much data points there are. If there's 10 pieces of data in Q3, how many pieces of data are in Q2? If there are 10 pieces in Q3, how many pieces of data are in Q2? How many pieces are in Q1? How many pieces are in Q4? Remember, it divides the number of pieces evenly into fourths, quartiles. So it has nothing to do with how much data is there. It has to do with the range of the data. By the way, if you were a basketball coach and you were ready to make some cuts on your team, where would you want to make your cuts from? Q1, Q2, Q3, or Q4? Q1. They've got the lowest amount of what? Points. And I'm not saying that that's the only thing about basketball that matters, because it's not. There's other things in basketball that make a difference. But how do you win basketball games? Points. Got to put points on the board to win a basketball game. So it definitely would play a big factor. Everybody good with this first example? Okay. So let's look at the your turn, which is on, I believe, the bottom of the next page. It's at the top of the next page, 343. Everybody see it? Okay. The box plots show the distribution of weights in pounds of two different groups of football players. Compare the shapes. Okay. Compare the centers. What's the other word that we use for center? Median. Compare the spreads. What's the other word we use for spread? Range. And I would say that we should also compare the interquartile range, because that's the most significant part of my box. So, if I want to talk about the shapes, it's interesting that even though they didn't give me a dot plot, I could give you an idea of what this would look like on a dot plot. Look at the data in Group A. Does each piece look like it's about the same length? In Group A, it's possible that the whiskers might be a little shorter than the box itself, so it might be a little bit clustered in the center, but it looks relatively evenly distributed. How about B? Are they evenly distributed, or are they closer together on one side than they are the other? They're closer together on one side. If they're closer together on this side, it's going to get skewed this direction. So although it might be in a group, it's definitely skewed which way? It's skewed to the right. So I can tell you a little bit about the shapes just by looking at a box plot, even though they didn't actually plot the points. Next, it said the centers. I can be a little more specific here. What's the center of A? I'd actually have to look at yours to make sure. It's probably 255. Right? It's kind of between 250 and 260. So it's about 255, 256. Right? How about Group B? What is it, about 272? It's a little above 270. $272. And by the way, if you had 271, 272, 273, right? It's somewhere in that ballpark. What's the range of it? And how would I find it? Subtract the highest and the lowest. What's the highest?
325.
And what's the lowest? Yeah, it's 335 maybe. What's the lowest? A? What's the lowest? 175?
No, 170.5.
No, probably about 175. 171, 172, don't know.
Wait, what?
I'm gonna use 172. How would I find the range?
Oh, so there's.
Somebody subtract them for me. 325 minus 172.
43. 43. I didn't pick my mind.
What's 325 minus 152?
43.
325 minus 172.
152. 3.
153, dude.
Dang, bro.
Remember, we're doing high minus low.
Oh, I see what I did.
What's the high and B?
325.
And what's the low?
175.
180 something, isn't it?
No, it's 189. 188.
Which players have an easier weight to predict? Group A or Group B? Group B, because their range is what? Smaller. By the way, here's one more thing. If you see this, it's often abbreviated this way. IQR. Interquartile range. And that interquartile range is the top of the box minus the bottom of the box. Remember, the box is your interquartile. Everybody good?